Turn to page 489, lesson 81, which is the law of cosines. Now, before spring break, we had learned the law of sines, which was A over sine A equals B over sine B equals C over sine C. And you pick any two of those, and because of the property of proportions, you could also have sine A over A, sine B over B, sine C over C. And remember, the uppercase C is the angle and the lowercase c is the length of the side across from that angle. So law of cosines is completely different, and at first you might not like it because it seems a lot more complicated, but it actually is a lot more useful than the law of sines. It's a squared equals b squared plus c squared minus 2bc cosine of a. Or you can say it's b squared is equal to a squared plus c squared minus 2ac cosine of b. Or you can say it's c squared is equal to a squared plus b squared minus 2ab cosine of c. And you might wonder how I can write those down so quickly without looking in the book. Well, if you have a over here, the other two sides have to go here and here. These same two sides go here and here, and the angle that's opposite this side always goes here. So here we have a B, we have AC, AC, across from the lowercase b is the capital B. Here we have C, this is AB, AB, angle across from C is C. So now you don't need to memorize all of those. Memorize whichever form you want to memorize for it. Just remember that whatever side this is, this will be the angle across from it. All right, so 81.1 is a triangle. And remember, law of sines and law of cosines, you don't have to have a right triangle for it to work. So this is 7, 10, x. This angle is M. This angle is 36 degrees. And this angle is Y. So we first of all have to figure out which we want to find first. So we have x across from the angle 36. That's the only two that we could actually work with because we don't know either one of the other two angles. We do know the sides across from them. But if we set this up, we can have x, which is the side, is equal to, use the other two sides, so 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of the angle across from x, which is 36. So now you can put this in your calculator just like that. You can put in, you're looking for the square root of this, so you would put square root in the beginning and then type this in just like it is. 7 squared plus 10 squared minus 14 times 10 would be 140 cosine of 36. So when we do that, we get, let's see, let's see, 49 plus 100 minus 140 cosine 36, enter, and I get 5.978. So x would be equal to 5.98. So now in the triangle, I have this is 5.98, this is 36, 7, 10, y, and m. Right, now the beauty of law of cosines is if there's going to be an obtuse angle, the law of cosines is going to give it to us, because if you think about it, an acute angle would be over here. Its cosine would be positive because the adjacent side is positive. If we have an obtuse angle in a triangle, it's going to come over here. Now the adjacent side is negative, so the cosine will come out to be negative. So we can use the law of cosines to find the obtuse angle, and then we don't have to worry about it. So in this triangle right here, if there was an obtuse angle, where would it be? Well, obviously it's not 36 degrees. If we have an obtuse angle, it's got to be across from the longest side. So 10 is longer than 7, so if there is an obtuse angle, it's got to be angle Y. So I'm going to find angle Y next, which means I'm going to start with the side opposite it. So it'll be 10 squared equals 7 squared plus 5.98 squared minus 2 times 7 times 5.98 times the cosine of Y. Now this one is a little bit trickier. This will be 100 equals 49 plus 5.98 squared is 35.7604 minus these multiplied 14 times 5.98 is 83.72 times the cosine of Y. All right, now see, this is multiplied by the cosine of Y. So we can't add it to these. So this is 100 equals 35.7604 plus 49. So that's 84.7604 minus 83.72 times the cosine of Y. So we need to get cosine of Y by itself. So we're going to subtract the 84.7604 from both sides. So that's 15.2396 is equal to negative 83.72 cosine of Y. Now divide both sides by negative 83.72. Make sure you don't forget the negative. That's what's going to give us the obtuse angle. So divided by negative 83.72 gives me cosine of Y is equal to negative 0.1820. Now how do I go from that to Y? Remember, anytime we're looking for an angle, we're going to use the inverse function. So the inverse function of this will be Y. And the inverse cosine of that is, let's see, second cos. No. Second. Sorry, I'm using a different calculator than what I usually do. There we go. So I get 100.488, which would round off to 100.49, or since we usually round off angles to one decimal place, it would be 100.5. Now, that's not what the textbook has. Why is that not what the textbook has? It's because we left the entire thing in the calculator until the very last step. So 100.5 is close enough to 100.6. Now if we go back, the only thing we don't know, we now know that this is 100.5 and this was 36. We need to find this. We don't need to use trig to find that, because there's 3 angles in a triangle and they all have to add up to 180. So add these together. That would be 136.5. Subtract it from 180 will tell us what that other angle has to be. So M has to be 43.5. So now we found all the missing pieces of that triangle. We didn't have to worry about whether it was an obtuse angle or an acute angle because this cosine value was negative. If cosine is negative, it's going to be an obtuse angle. And that's the beauty of using law of cosines, because you don't have to worry about that. All right, let's try another one. On page 490, we have this triangle. This is y, this is 5, 8, 7, z, and x. Now in this case, we don't know any of the angles. So again, if there's an obtuse angle, I want to find it first. So which one would be obtuse if there is an obtuse angle in this triangle? Remember, it's always across from the longest side. So the longest side in this triangle is 8. So the angle across from 8 is y. So we're going to find y first. So that means we start with the side opposite it. 8 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of y, because it's across from 8. All right, so we have 64 equals 25 plus 49 minus 10 times 5 is 70 times the cosine of y. Again, remember, this cannot be combined with these because these aren't multiplied by cosine of y. So 64 equals 5 and 9 is 14. 74 minus 70 cosine of y. And we want to get this by itself. So we subtract 74. We get minus 10 is equal to minus 70 cosine of y. And we divide both sides by negative 70. So cosine of y is equal to positive 1/7, which is 0.142857, and so on and so on. I'm just going to leave that in the calculator. And that's a positive cosine. So what kind of an angle are we going to get if we have a positive cosine? That's right, we'll get an acute angle. So we take the inverse cosine of this. So let's see. And we get 81.8. Okay, so 81.8 is right here. Now, once I have that angle, do I need to use the law of cosines to find the rest of it? No, because now I have a pair. I have an angle and I have the side across from that angle. Now I can use the law of sines. So the law of sines let's see, we've got this triangle. Now we know that that is 81.8. This is 5, 8, 7. This is x and z. It doesn't really matter which one we find because they're both going to be acute angles. If there was an obtuse angle, it would have been this one. It didn't come out obtuse, so we know the other two can't be obtuse either. So I'm going to say 8 over the sine of 81.8 is equal to 7 over the sine of x. And now we cross multiply. So we get 8 times the sine of x is equal to 7 times the sine of 81.8. And then to get the sine of x by itself, we divide both sides by 8. And then to find out what the angle is, remember, anytime you're looking for an angle, you're going to use the inverse sine. So x will be equal to, I'm going to take the inverse sine, so put that in my calculator, and I'm going to say 7 sine 81.8, close my parentheses, divided by 8, and then close my parentheses again. Make sure I'm telling it to multiply the sine of 81.8 times 7, and then take that quantity and divide it by 8. And it's telling me there's a domain error, so let me try this again. Inverse sine of 7 sine 81.8 divided by 8. 60.0. So x equals 60.0. And once I have those two angles, what do we need to do to find z? Do we need to use trig? No. We know two angles of the triangle. Add them together. 81.8 plus 60. And if we subtract those from 180, z is going to be equal to 180 minus 141.8. So z will be equal to, let's see, 38.2. So z equals 38.2, and we found everything that was missing in that triangle. All right, now then, let's move on to 81.3. This is on page 491. Again, we've got this triangle that looks something like this. This is M. 14, 10, K, 28 degrees. And this is angle B. Okay, well in this case we have to find side K first. We can't find M because that would be two different variables. That would be K and M that we would have in the same problem when we can only have one. So we have the other two sides if we use this first. So that would be K squared is equal to 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of the angle across from K, which is 28. So we can put this entire thing in the calculator. K will be equal to the square root of this. So that would be 100 plus 196 minus, what is that, 280? 28 down 280 times the cosine of 28. So put that in your calculator, round that off to 2 decimal places, and let's see what you get. I'm going square root of minus 280 cosine 28. I get 6.98. What do you guys get? That is correct. So if you don't get that, go back and put it in your calculator again. And remember, always check to make sure your calculator is set in degrees. All right, so now we still need angle B, but we need angle M. So I'm going to find angle M first. Why would I find angle M first? Because 14 is the longest side. If there's going to be an obtuse angle, it's got to be across from 14. That would be angle M. So I will say 14 squared equals 10 squared plus 6.98 squared minus 2 times 10 times 6.98 times the cosine of M. So this is 196 equals 100 plus, I don't know what that is, squared. 48.7204 minus 20 times 6.98, 139.6 times the cosine of M. So this is 196 equals 148.7204, and then minus the 139.6 times the cosine of M. And remember, these can't be added because there's a cosine M here and not here. So we're going to subtract this from both sides. Let's see. So 196 minus 48.7204 is 47.2796, and now we're going to divide both sides by what? Negative 139.6. Negative 139.6. So cosine of M is going to be equal to a negative number, which means that yes, that is an obtuse angle. That divided by, now I'll take the inverse cosine of that, and I get 109.8. Let's see, that number was negative 0.33868. So M was 109.8. And once we have these two angles, we don't need trig anymore. We can just add 28 plus 109.8 and then subtract from 180 to get B. So B will be 180 minus 137.8. So that's 42.2 for angle B. All right, lots of good stuff with law of cosines. There's no ambiguity. We don't have to worry about whether it was an acute or obtuse angle. It'll always come out right using law of cosines. All right, next. This is a typical problem from the ACT or SAT. This is on page 492, and it has this drawing. Has this cable that's attached to a pole, and this is 50, this is 150, and this angle is 15 degrees. This is angle B, and this is length L. So it says, the figures show two cables that are attached to a vertical tower from a point on the ground. The angle between the two cables is 15 degrees. Okay, so these are the two cables. They're holding this pole up. They're called guy wires. The angle in between them is 15 degrees. The longer cable is 150 feet long. Well, obviously this is the longer cable. It's going from down the same point to a higher point on the pole. The shorter cable is attached to a point 50 feet below the top of the tower. Find the length of the shorter cable. That's this right here. Well, if you'll notice, this right here is across from this angle right here, which we don't know. So we can't use law of sines. We can use law of sines, but not to find this or this, because that's two unknowns. Let's see, we can't use law of cosines to find this or this because we'd have both of them unknown. So what's going to happen is we're forced to find angle B to start with. And to find angle B, we're not going to be able to use law of cosines initially. Initially, what we're going to have to do is use the law of sines to find B, because we do have a pair, 50 and angle 15. So we can say 50 over the sine of 15 is equal to, we can say 150 over the sine of B. All right, now you look at angle B. Now you tell me, is that an acute angle or an obtuse angle? It has to be obtuse. There's no way that those two cables would be connected and this would be an acute angle right here. It just would never work. So just keep in mind that we know our answer has to be an obtuse angle. So when we cross multiply, we get 50 sine of B is equal to 150 sine 15. We divide both sides by 50. 50 goes in here 3 times, so the sine of B is equal to 3 times the sine of 15. So I'm going to take the inverse sine of this, and I'm going to take the inverse sine of 3 sine 15 divided by, oh, never mind, not divided by anything. That just canceled out. So 3 sine of 15. All right, so I get 50.9. Now, does that look like 50.9 to you? No, it's not. Remember, from the law of sines, this angle has a positive sign, and so does this obtuse angle have a positive sign. So this is 50.9 in here, but we need this obtuse angle. So we have to take 180 and subtract 50.9 from it to get the obtuse angle, which this actually is. So 10 minus 9 is 1, 9, 7 minus... So it's 129.1. B is actually 129.1 degrees. We still don't have what they asked us to find. Well, let me scroll to the next page. So what we do have is we have, this is 50. This is 129.1. Let's see, this is 150. And we need this. We know that this is 15. We still have to know this angle right here in order to find this. So can we find this angle right here? Yes. We have a triangle with 129.1 and 15 degrees. Add them together. It's 144.1. So this angle right here is going to be 180 minus 144.1. So that angle up at the top is 35.9. This right here is 35.9 degrees. Now, we could either use law of cosines or we could use law of sines. It doesn't matter. I'm just going to use law of sines. So I'll say L over the side angle opposite that is sine 35.9 equals 50 over sine of 15. I could have used 150 over sine of 129.1. I would have gotten the same answer. It doesn't matter. So now I cross multiply. I get L times the sine of 15 is equal to 50 times the sine of 35.9. Divide both sides by sine of 15. Okay, now, do I have to use inverse sine to find this? Are we finding an angle at this point? No, we're finding a side. So no, we do not use inverse sine. We use regular sine. Type it in just like it says. So, parentheses, 50 sine 35.9. Remember, you got to close that twice because it'll put a parentheses around your angle. And then that divided by sine of 15. So that gives me 113.3. So that's what the length of the shorter cable is 113.3. Now, was that a lot of work to find the length of the shorter cable? Yes. But just think about it. Between the law of sines and the law of cosines, we were able to find any piece of this triangle. So now that you're equipped with the law of sines and the law of cosines, you're good to go. You can find any missing piece of any triangle. Not just right triangles, any triangles. All right, so that's it for that lesson. Make sure that you upload this assignment to Canvas before the beginning of your class on Tuesday. And also, just like you would if we were in class, write at the very top how many problems that you did. So I'll be able to record that. Make sure you upload every page of your homework and not just the front page or whatever you might try to do. I did put directions in. There's an app that you can get on your phone that I mentioned in the announcements. It will make it easy to upload. It's called Genius Scan. It automatically uploads a picture as a PDF, and you can upload that into Canvas directly. All right, so if you have problems, you can email me or you can call me on my cell phone. So either way, you can get in touch with me if you need help on a particular problem or you just have questions. All right, I'll talk